So, alright. So here's the thing. That one doesn't work. You have to use yellow. So, come on, there are yellow ones back there. Go grab it. Okay, so the only way to create fair groups, do you know what that method is?
No.
People that stand your same caliber.
Not rock, paper, scissors.
Wait, what's the...
We have to, Ethan. I'm in the front of the room, and this is starting to get irritating. I'm sorry to call you out in front of everybody, but when I'm in the front of the room, eyes up here and pay attention. Is that clear?
Yes, sir.
Okay. So, the only fair way to assign groups, because you are all equally capable, is to randomly generate them. So I have everyone's name here in a random team generator, and we're about to find out where you are going to go based on that. The number, group number, goes along with the numbers in this room. Okay? So find your name and move with your stuff to there. So group 1 is Wesley, Keandre, Aiden, and Winter. Group 2, excuse me, it doesn't take talking to move. Group 2 is Jaden, Anaya, Caitlin, and Emily. Group 3 is Coda, Madison, or Maddie, Lillian, and Nathan. Group 4, Jordan, Jamie. Excuse me, I think I just said that it doesn't take talking to move. Y'all are going to send me over the edge today with all this garbage. Follow directions. Okay, go with the stuff that you have. We'll talk about that in a second. No, just go ahead and drop right there for today. You drive all, Jordan. Jordan, you can see it right there. Look up there.
You guys get it too.
It's not mine.
What is this?
Why do I have so many people back there in that group? Come on, let's move efficiently and quietly. Alright, so we got Aiden and Winter here. Alright, group 2. We got Jaden, Anaya, Caitlin, and Emily. Group 3, we've got Coda, Maddie, Lillian, and Nathan. Group 4, we've got Thomas, we've got Addison and Jordan. We're missing Jamie. Hey Thomas, if I'm up here teaching, is it going to make sense for you to have your back to me, bud?
I'm saying because the way the desk is.
But turn to the side, and then you can write with that to your side.
Alright.
Okay? I feel like you made that so much more complicated than it had to be. Alright. Group 5, we have Ezra, Brooklyn, Janiyah, and Joey. Group 6, we have Devin, Barry, Lee, Ethan, and Tamarlin. And group 7, we have Kyla, Trent, Taylor, and Peyton. Alright. I may move just a little bit around to help make it easier, especially with Thomas, to be able to sit elsewhere because of his leg, things like that. So these are for the most part going to be the groups. I may make 1 or 2 switches tomorrow just to make things a little bit easier. From there, we have our new groups. Let's look at our bell ringer. So some of us are saying we don't know about how to find the slope of a line, but Okay. So, quite a few of us had 2/3 as the most common answer. I see a -4 up there. A 6x times 4y. I see a 4 divided by 6. So, I see a 2 and a 6 showing up pretty regularly. For someone who felt pretty confident about their answer, can you tell us how you were thinking about slope?
The way our teacher told us last year, and like the first what do you call it? The line, like it stopped at -4.
Okay.
See that it didn't at -4.
So it ended at -4?
No, it stopped like what? I need a picture of the line.
Okay.
The way it was. Yeah. Right there. -4.
Okay, so you're looking at this -4 right here?
Yes.
That point?
Yes.
Okay. Does anybody want to add on to or push back on that idea of that being the slope?
I believe yes, because that's what I do.
Emily?
Oh, you're going to read a little bit of this, but I was thinking of the equation, the y equals mx plus b.
Okay.
And since 2 over 3 is multiplied by x, then that would be m, which is the slope. So that's what
So you were thinking that this was the slope? You see how that m lines up with the 2/3?
Oh, so that's what slope is.
Partially, there's more to it than just that. I heard other people correctly talking about slope. Now, okay, so let's pause for a second. This is -4, right? Now, that's a point though. Is the -4 the x or the y value?
No.
Why?
The y is -4. What's the x?
Six.
That x value is +6?
-6.
That's a 0. Y'all are looking over here at the x-intercept. I'm talking about this point. That x is 0. The y is -4. Notice if I start at the origin, does it go left or right at all?
No.
No. So the x is 0, and it goes down 4 for a y of 4, or y of -4. Okay? That's called not slope, but y-intercept. It's called a y-intercept because that's where the function intersects the
The line.
Slope.
say it again, Bailey?
The y-axis.
The y-axis. It's called a y-intercept because that is where the function intersects the y-axis. Similarly, this 6 that some of y'all were talking about, that's not a y-intercept, that's an x-intercept because that's where the function
Me.
Intercepts the x-axis.
intersects with the x-axis. Okay? So that's our x and y-intercept. Now, I'll go ahead and agree that if you look at that equation, as part of the reason why I left the equation in there, yeah, you see that the slope is 2/3. Notice right here, you see that -4? Didn't we say -4 was the y value, the y-intercept? That's why the name of this equation, does anyone remember the name of this equation?
Slope-intercept form?
Yeah, what's this part right here? That's the slope. This is the y-intercept, so it's called the slope-intercept form of what? What is this describing? Of a line.
See, this one I
That is the slope-intercept form of a line. It's got the slope, it's got the y-intercept of that line. So that is something with lines. Now I need you to hear me very clearly on this. You will want this note. This is not the focus of our next unit, but that packet that says linear regressions, on the front of where it says linear regressions, I would make this, actually, not where it says linear regressions, go to page M1-167, where it says like a glove, it's lesson 1. Make this note about slope-intercept form of a line at the bottom in that white space. M1-167. This is known as the slope-intercept form of a line. Y equals mx plus b. Yep, where it says lesson 1 like a glove in that white space at the bottom. Make a note to yourself about the slope-intercept. Thomas, you see that blank space at the bottom? Yeah.
Wait a second, what was it?
See, this is,
I know we're not used to data analysis, but we're now going to look at some data analysis that ties in with what you studied in middle school with lines. So again, that's the slope-intercept form of a line, y equals mx plus b, and so we can identify that my slope is 2/3 from that. But we are missing an important detail about that slope if that's the only way that we find the slope. Okay, so let's talk about that. You say rise, and you say over, run. Okay, I want to pause though, and I know that you're going to look at me like I'm crazy, and most of my algebra students do as well, but I need you to stop saying rise over run. Because here's the thing. Over does not mean anything mathematically. Say that again. Isn't that a division symbol?
Yep.
What slope is rise divided by run. There's a lot of algebraic concepts that if you don't think about that as division, it's going to hurt you. So stop saying over, start focusing on that idea of it's rise divided by run. It's going to make things easier. It's also going to help us connect some things in a second. So trust me, do rise divided by run, not rise over run. And so when we're talking about rise divided by run, what are we referring to?
Y-axis.
Not necessarily that y and x axis, but the x and y coordinates or values. So we have a point right here, don't we?
yes.
Let's say I just pick another point. Does it matter what point I pick? No? Let's say I pick this point. It might be hard for you to see depending on where you are, but how much, to get over to this point, how much does this rise?
2.
Oh,
The rise is 2. How much is the run?
3.
2 divided by 3. So the slope, rise divided by run, would give me 2 divided by 3. Does that match the equation? Yes.
I was right the first time.
Say it again, Code.
I was right the first time, but I changed.
I know, stop doing that. Trust yourself. We know that slope is rise divided by run. I would imagine that's something that a lot of us heard in middle school pretty regularly, right? Maybe a little bit, hopefully. A little bit. Slope is rise divided by run. Now there's a couple of things I'm going to talk about with that. First off, when we say that it rises to, is that idea of rising, is that like adding, subtracting, multiplying, dividing?
Because it's
just
going
going on.
It's going up, so it is adding 2. Then it's going to the right. What is that doing?
Divide.
Adding.
It's still adding by 3. Can it continue to go up by 2
Mm-hmm.
and to the right by 3?
Mm-hmm. There's the value.
Does it continue to go up by 2 and to the right by 3?
Mm-hmm.
Does it ever quit doing that?
No.
So what you're telling me is to create that line, it is repeatedly adding.
Yes.
Yes? That's what's happening?
Yes, sir.
Hey, what mathematical operation shows repeated addition? Hey, what's happening between this slope and the x? Because what makes a line is this idea of repeated addition. When we talk about lines, you probably talked about the fact that they have a constant rate of change. Does that sound familiar?
No.
Okay, if it doesn't sound familiar, that's how most teachers talk about it. But I'm going to go a step further to explain this equation. It's not just a constant rate of change. Lines have constant. What's happening? It's repeatedly. So it's a constant additive rate of change called slope. The constant additive rate of change is what creates a line. And that constant additive rate of change is known as slope. I would. That is one of the most fundamental elements of mathematics that most students miss out on. Jaden, did you get that written down? Okay. And so one of the things that you don't need to write down, but I do want you to notice is this. Could I have skipped this middle point and just gone straight to here? But now how far would it have risen?
4, 6,
And then it would have been to the right 6. So that would be a slope of 4.
6.
But what does 4 divided by 6 simplify to?
2 over 3.
2 divided by 3. Remember, we're going to try to stay away from saying over. Remember, Joey, this right here is a division symbol. So you either want to say 2/3 or 2 divided by 3. Actually, I think there's someone over there that said 2/3. Coded it, right? So notice, does it matter which points we choose? No. It's still going to be a slope of 2 divided by 3. Exactly. You can even pick a point like right here. It's going to be harder for you to see, but if I go to this point right there, it's actually only going to rise 2/3 of a unit and go to the right 1. And what's 2/3 divided by 1? 2/3 still, right? So you could pick any points, whether it's a fraction of a point or not, that slope, that additive rate of change is going to be 2/3. That's what makes a line a line. Okay? Yes, Nathan?
It's just a never-ending constant pattern.
Not just a constant pattern, a constant,
Rate of change.
not just constant rate of change, a constant additive rate of change, right? It's the idea that it's repeatedly adding all the way through.
So, what was the bell on your answer?
The bell ringer question is, what's the slope of this line? The answer is 2/3. I'm trying to show that we can identify that slope lots of different ways. We can find it in the equation, y equals mx plus b. We can find it in the graph by that 2/3. And here's another way that you can find it, and I want you to pay attention to this last one because it's going to help you in a second. If I were to just take any 2 points, for instance, I'm going to take the 0 and -4, and I'm going to take this point right here, which is 3, -2. I want you to look at your y's. What is happening to go from -4 to -2?
Plus 2.
If I subtract 2, it's actually going to get more negative. I'm actually adding 2. What about to go from 0 to 3?
3.
Wait, so this is the same as my rise, and this is the same as my run? In math and in high school level math, you're going to learn about a different way to write rise and run, where we say that the slope is, and that's the Greek letter delta, and that Greek letter delta means change. Okay? That Greek letter delta means change. So I want you to notice this rise. What's changing, the x or the y? Y. If things are rising, the y values are changing, okay? So we would say that it's the change in the y
Minus the change,
divided by
the change in x.
the change in the x. That's what that's saying. This is another way to write rise divided by run. But this will work in graphs and it'll work in tables. That more only works in graphs. Okay? So that's the last detail that I want to add there about slope. But I do want you to notice, right? We can find that additive rate of change anywhere, especially in tables. You can see the +2 and the +3. If I were to do that next point, the x-intercept, it'd be 6, 0. What happens to go from -2 to 0?
Plus 2.
+2. What about to go from 3 to 6?
Plus 3.
You see how we still see that additive rate of change there? Okay. It's all over the place. Math at its core, I mentioned this at the beginning of the year, is the study of what? Patterns and relationships. We're starting to really get into true math. We've been in data analysis for a long time. We're going to get into true math at this point where we really get to see more of patterns and relationships. We are still doing some with data analysis here though. But that's a recap of slope. What I want us to do right now is this. On that same page, like a glove, it has number 2 there on the, under warm up. I want you to find the slope between those two points. So I'm going to add a question, expression. What is the slope between, what's the 2 points? And what again? All right. So I'm going to send this out as a poll question. Let's try to figure out the slope between those two. Think about what you could do, how we found slope before. I will say this, the calculator's not going to help you figure out the answer. You're going to have to think. You'll have to enter the answer in the calculator. But think about how we found slope. There are multiple ways to get the slope of this between these 2 points. Think about how we found slope.
Well, the x value doesn't increase, it decreases, so that's subtracting.
Okay, so the change in x you're saying is
It's negative.
Okay. So keep thinking about that. Use those different forms. Guys, it's not necessarily a silent endeavor. You can work with each other. You will need to write stuff down. I can almost guarantee it.
It's negative.
Can you create a table? Heck yeah. Sure. Be quick. We got something work.
Negative 2.
But make sure y'all are working together. If that's an idea you have, talk about that with the group. See if they like that idea and how you can use it.
Yeah, because
Thank you, sir.
your run's always positive.
It's up on the board still, bud.
Your run's always positive.
Okay. What did we say this means? Here, let me ask this question actually. Because it's going to be hard to find the slope just looking at those 2 points. What did we create in order to find our slope easily?
Yeah.
Well, think about the things that we saw in the calculator. I can't help you if you're not going to give me something.
I don't know what, I don't know, I don't know.
Joey, calm down. You do.
I
Joey.
just said I don't know.
But Joey, you do know. Listen to the question again. I'm not asking you how to get the slope. I'm asking you, what did we create? What did we look at to find the slope up there? Think about the ways that we represented the line. We had it first on a what? Started with a G. When we looked at rise divided by run, we looked at the left. Starts with a G. Talk about Brooklyn. Brooklyn, you're not in a group with her. Don't talk to her. Don't touch her. No. I've only got 2 answers in there. All right, so let's cover this, or 4 answers in there. Listen, what were the 2 different mathematical representations we looked at to find slope? We looked at a graph, and we looked at we usually call it a table, okay? So you can create what 2 things to help you find this slope? A graph or a table. You just have to graph the points or create a table with those points, and then you can find the slope. Try creating a graph. I think they're both valid. Guys, I only have 10 answers in there. Come on.
My question is,
He said, but the change of the X, right?
It's just a division. That's what I said. It's divided by. So, what are you trying to do? Fraction, right? But what are you trying to put in the numerator? What are you putting in the numerator? That's called the numerator. It's all part of the fraction. What are you trying to put up there?
okay, I don't log into the computer and then get on.
Okay, so put 2. And then what does that mean? What mathematical operation is that? So put divided by. And then what's the number down there? Guys, I need y'all to hear me very clearly on this. Because I'm about to just move on because it cannot take us this long to do slope. But this is part of the reason why I know we need more practice with this. So we'll get more practice with this tomorrow. But y'all kept trying to say stuff like 2 over 3, right? But what does that fraction bar mean again? Division. So to make your life easy in the calculator, just literally type 2 and then hit the division symbol 3. It means the same thing. Don't make it harder than that. Don't say 2 over 3, do 2 divided by 3 and then type that in. Well, unfortunately, we aren't thinking and we're just doing what everyone else is doing. Because how do we calculate slope?
Y equals B.
So remember, that's not slope, that's the slope-intercept form of a line. How do we calculate slope? Rise divided by run, right? So if I start here, the rise, well, 1, it's going down. How far does it go down? 1, 2, 3, 4, 5, 6. So what's supposed to be in the numerator? How many of us put -6 in the numerator? Not many. It's rise divided by run. You've got to put the rise first. Divided by how much is the run, how much is it going to the right? 2, because it's to the right, it is
Negative.
positive. To the right is positive. And what is -6 divided by 2?
-3 divided by 1.
Or just -3. Right? -3 divided by 1 is just -3. Again, this is why you need to remember it's rise divided by run or the change in what first?
Y.
Y is first. To go from 2 to 8, what's happening? That's adding 6. Ooh, we got -6 earlier. Well, let's keep going. To go from 5 to 3, that's -2. Can you let Wesley in, please? So the change in y divided by the change in x is why you always want to write your formula down instead of just assuming. Write your formula down. What's the change in y? Divided by? Not here. Positive 6, isn't it?
Yes.
Oh, yeah, what group was Wesley in? He was right there. Okay. Divided by -2. Hey, what is 6 divided by -2? 3. Does it give us the same answer?
Yeah.
Yes. Okay, so it doesn't matter which direction, but we need to pay attention. If you are calculating slope, if I'm asking you for slope, you either need to do rise divided by run, which is most easily found on the graph. So if you need to make this note to yourself, make a note for rise divided by run. You want to graph to do rise divided by run. If you want to do change in y divided by change in x, you need to create a what? Table, or you could also use a graph there. Table or graph. But you need to write out your formula. Many students mess it up and flip the numerator and denominator because they're not writing out their formula. Take the extra second to write the formula out. It will help you significantly. Yes, Joey?
I'm still very confused.
What are you confused by, bud?
Everything.
No, it's not everything, because you were the one who told us several of these details earlier.
Because I only told the details that were simple math. Like a negative 3 divided by 1 is negative 3.
But, Joey, what's the formulas?
Y is the next equal to B.
That is only the slope-intercept form of a line. What are the formulas that are right there?
Rise divided by 1.
So if you create a graph, you find how far it rises, meaning going up or down, and it's going down 6. Run is how far left or right, and it's going to the right 2. So it goes down 6, negative 6, to the right 2, positive 2. So rise divided by run.
Ah,
That's it.
I see what you did.
Yes, ma'am.
I have a question. Why do we use like some of the Greek letters in that?
Because there are so many different things that we're trying to represent that we don't have enough in just plain English to represent them all, is part of it. A lot of it also is because Greek mathematicians were the first ones to discover a lot of mathematical ideas. Legitimately. That's a good question. But yeah, we use Greek letters a lot of times because Greek mathematicians discovered ideas. Okay, what are your questions right now about slope? Going once, going twice, sold. Okay, I planned on doing an activity with you starburst today. We don't have time for that.
Said Star Wars?
Starburst. Starburst, my man. Starburst. Starburst. Okay, so let's do this. We're going to come back to the starburst part of the activity. Tomorrow is when we'll do it. This is what we call the candy grab activity. So you should, pause, you should already have a sheet on your desk called the candy grab activity. You will want to put this in at just before this lesson that we've already started to look at. We're not done yet. Don't pack up yet completely. Yes. Did you not No, it's not time to go. I literally just said, don't pack up. Hold on. Wesley, here's this. You'll need a whole bunch of. I'll have to find the candy grab activity. I said it somewhere. All right. I'll get to you at the end of the class. So here's the thing, candy grab activity. That's where we're about to start. Well, we'll have to start tomorrow. And it's going to help us talk about making predictions. Now, we are going to look at a combination of what we just looked at. What was the unit we were just studying?
Linear regression.
It involved standard deviation, it involved IQR, but that was to help us analyze what? Data. We're going to look at a marriage between, not a marriage, but a union, they coming together, of data analysis with linear ideas. Okay? So the unit we're about to look at is a marriage between data analysis and linear ideas. And so we're going to use the candy grab activity tomorrow, and we're going to have probably 10 of y'all or so come up here and do your best to grab as many starbursts in your hand at a time. After that, okay, I will be passing out a handful of candy to each person so that you can enjoy some starbursts when we do the rest of the lesson, but not yet. So, we're going to then look at this idea of least squares regression lines and get back to candy grab activity. I'll give you the squared up task later. I'm going to come back to all of this. Hold on. Stop packing. Did I tell you to pack? Okay. Okay, so, alright, I'm trying to think time-wise. We don't even have time to do this. Alright, so here's what I'm going to do. I'm going to pause for a second, I'm just going to talk. You can pack up. Once you're done packing up, then I'm going to have a conversation. So, chill there for a second.
Wake up.